Today I have a Panasonic DMR EH50. This is a DVD recorder that records on DVD+R, DVD+RW, DVD+R, DVD+RW, and DVD RAM discs, and it also has a built-in 100 gigabyte hard drive. This is my own personal unit I've had for a number of years. I use it all the time, or at least I did until it died. It's completely dead. I have no idea what's wrong with it. Let's see if I can fix it. So there's the front of my DVD recorder, DMR EH50. This is a hard drive and a DVD recorder. I've had this unit for many years, at least 10, probably closer to 15. And I bought it from a client at work that wasn't using it. As I say, I used this I used to use it to record TV shows on. The reason I don't have any VHS tapes of TV shows, too many anyway, I have a few Super VHS, but I used to do all my time shifting using this machine. Record to DVD RAM or record to the hard drive. And I used to use this for all my time shifting stuff before we had DVRs, right? When we just had satellite TV back in the day. So it got lots and lots of hours on this thing when I was using it for recording off my satellite dish. So this is my personal Panasonic DVD recorder with a hard drive built in. This one has a Maxtor, what is it, a 160? No, 100 gigabyte. Maxtor 100 gigabyte hard drive. And a DVD recorder that supports DVD-R, +R, -RW, +RW, and DVD RAM. So this supports all the formats. I believe it'll support plus. Yeah, it does. DVD RAM, DVD-R, DVD-RW, and +R. Might not do +RW, but I think it does. But it does DVD RAM as well. Has S-video and video inputs on the front. This is input number 2. Input 1 and 3 is on the back here. And it has outputs 1 and 2 plus component and optical output. This unit is one that I've been using for years to archive material, and it worked fine until we had a power failure, and then when the power came back on, the unit did not start. So I have to think power supply, and that's where we're going to start. So I'm going to remove the power supply board, and we're going to troubleshoot that together. So we'll undo the connector. It's nice that these ones have a power supply that can be removed from the unit itself. Looks like this processor's been getting a bit warm, but we're not too worried about that because I don't believe there's a problem there. I think the problem's completely contained to the power supply, and the problem is going to be failed capacitors. There's already a couple here that have got telltale signs that they're shot, like that one is leaking. So is that one. So those are definitely gone. We're going to put the ESR meter on, and we're going to test them all, and we're going to change all the caps in here that are testing bad. This unit has lots of hours on it. I bought this unit a few years ago from a client that wasn't using it, and I said, what do you want for it? And they said, oh, give me $50 for it. So I gave them $50 for it. It's obviously worth a lot more than $50 in working condition, as all these DVD recorders are quite valuable these days, especially the ones with the hard drives, just because they haven't made these in a long time. And what's particularly nice about these is if you're using them to archive like recordings, like TV shows, you can record. I use it to record off my cable box when I want to make a copy of something that I don't necessarily need to keep in HD, but I can record through the AV inputs. I record it onto the hard drive, and then I can go back, and using the remote, I can mark the start and end of the commercials and delete them. And then what I end up with is I end up with a program stored on the hard drive that has no commercials in it. Then I can take that recording that's on the hard drive, and I can dump it over to the DVD and make a DVD copy that I've taken all the all the commercials out of. And that's one of the things I've been using this machine for the last couple of years, is just for archiving stuff off TV. Now I don't do much archiving off TV now in standard definition anymore. I do everything in HD, and I use my my Hauppauge HD PVR to do that, because I can record with the component inputs and record in 1080. But for something, if I only want it in standard definition, I use this. But I do use this a lot for archiving clients' home videos, because it does do a very good job of recording. This and my Toshiba, but this one gets used a fair bit too. And especially if they want to compile a bunch of tapes together onto one disc, I'll record them onto the hard drive. That way I can assemble multiple tapes of different lengths. Like I can put a tape in and let the tape go. It might be a 2-hour tape, but there might not be 2 hours worth of stuff on it. So I'll just let it go and let it run, and then after the fact I can come back and I can delete. I can go find the end of the recording and delete from where the recording ends to the end of where the recording was made, and then of course that way I can maximize the content. If someone's got a bunch of tapes and they want them all put on as few DVDs as possible, I can do them onto the hard drive first and then transfer them over to the disc. And that's generally what I use this machine for, is for that type of stuff. So I'm going to get the machine out of the way. We're going to concentrate on the power supply. Now, even though this thing has not been plugged in for quite a while, I've had it unplugged for several days. We're just going to make sure that everything is completely discharged. So I'm going to go through and discharge all the capacitors before I get in here with my ESR meter and start measuring. Because the fastest way to blow up your ESR meter is to measure a charge cap, especially when you don't have protection on it, which mine doesn't. Okay, these are discharged. I think the problem that we're going to have on this is, I know these ones are bad because you can see that they're bulging and leaking, but I don't think this is why the thing's not starting. I think maybe the display that was a bit dim might be due to some of these caps, but the reason it didn't start is I think probably one of the little caps on the primary side, which kicks a pulse when the power comes on to start the oscillator. I think probably one of those is going to be the problem. So we'll measure and test. Of course, I'll test that fuse first. It doesn't look like it's blown, but who knows? We'll use the ESR meter for that as well. It'll measure low ohms. Fuse is fine. Okay, let's start measuring caps. Main filter, I'm sure it's fine. My concern is this little one over here. It's a little 68 microfarad 35 volt. We'll see how it looks. Where is it? It's that one right there. Oh, it's not measuring bad actually. It's measuring, well, actually, you know what? It's across a, looks like it might be across a coil. No, it's not. That one's probably measuring okay. 0.03. That one's okay. I suspected that one might be at fault, so we'll just look at these ones on the secondary. Definitely these ones that are bulging are going to be bad, so they're going to get swapped out no matter what. But we'll test all of them. Now, the ESR meter, of course, can measure capacitors in the circuit. 0.2. This one is a 47 at 25 volts. So 47 at 25 volts should be 15 ohms or less. And this one here is coming up at 0.1, so we know that one's okay. The next one to it is a 220 at 25 volts, and this one's probably also okay. Yes, that one's okay. Here's one of the ones that I suspect is bad. Yeah, 4.8, definitely. That's one of the ones that's bulging. And here's another one that's bulging over here. 15, 14. That one's definitely bad. And as is, this one here is going to also be bad. That's 10. Those are the three that stand out. But let's test the other ones as well. Like, let's test this one here. That one's measuring 0. But I think there's another one in parallel with it. 0. Those ones may be okay. Those are big. Those are big filters. What are the value of those ones? They are 1800. So yeah, those are probably fine. I think it's probably going to be limited to these small ones that are showing signs of leakage. Here's another cap here. 0.03. That one's going to be okay. How about this one here? 0.07. That one's okay. This one here. .06, that one's okay. I think it's just going to be those three that the tops. Oh, 9.7. Oh, that's one of the ones I measured before. That one's bad. I think it's probably going to be limited just to those ones that were showing signs that they had failed. Yeah, that one's good. A couple more down here. 0.1. What is that? What size is that? 1000 at 16. Yeah, that should be okay. 0.2 is where a good one would be rated. So I think we just got 3 caps to replace on this one today. 0.03. That's looking good. I think the only ones we're going to have to deal with are these 3 caps. So let me go find some. We'll change those 3 and see if my DVD recorder starts working. What's interesting is these are the caps that are all measuring good. Are all, these look like these are Panasonic. These are Matsushita. You can see the labeling on them, these gold colored ones. These are all good, right? These are all Panasonic branded capacitors. These Elnas here are also testing good. The ones that are testing bad are, what are these things? What brand are these? They're Elnas. That's an Elna. That's a bad one. And this one here is also, I think this is an Elna. So it's interesting that the ones that are bad, they're Elnas. But these ones here are testing good. This is the third one. All 3 of these are Elna. So I've got 680 at 10, 680 at 6.3. They're all 680. 2 of them at 6.3 and 1 at 10. So let's see what I can find. I'm probably going to have to go up to 1,000 because I doubt that I've got a 680. I got 3 1000 microfarad caps here, 25 volts. 2 of them are Panasonic, and one of them's a Rubicon. I know I'm going to hear it from someone who's going to lambaste me for going up in value on capacitors. And you can save your opinion, okay? Because I've been going up a little bit on value, especially on power supply capacitors, for 35 odd years, and it's never ever caused an issue. As long as your voltage is higher than the working voltage, and if you go up a little bit in capacity, you're generally not going to cause any problems, because anybody that knows anything about capacitors knows the tolerance on them. If you have typically 10% down and 20% up. So 1,000 microfarad capacitor can be anywhere from 900 microfarads to 1,200. That's considered acceptable. So a 680, if it was on the higher side, would be getting pretty darn close to 1,000 microfarads. It's a power supply filter, so they're going to be fine. So let's change them. Where capacity becomes a little more critical is when you get into signal processing, bypass capacitors and stuff, where you're coupling from one circuit to another. That's when it becomes a little bit more of an issue, because going to a larger capacitor would increase the amount of signal. It would increase the capacity. It would change the resonance of the circuit and change the band pass and everything. So when you're dealing with circuits where you're coupling audio or video or RF signals, you generally have to stay in closer to the designed value. But when you're dealing with power supplies, their only job is to filter out the ripple. So bigger is actually better. There's one. The next one is down here. And the third one is, where was that third one? It's over here. Third one's right here. And yes, when you're dealing with electrolytic capacitors, it goes without saying, they are polarity sensitive. So get them in the right way. The board is marked with a little plus and a negative sign. On most devices, some things don't, but most brands will silk screen the board so you can see which way they go in. If anyone's curious about when this thing was made, the hard drive is date coded 3rd of October 2005, so it was made sometime after 2005, probably 2006 I would think this model was out. Oh, here we go, we have a date. It was made the 7th of October 2005, and the hard drive was made the 3rd of October 2005. That's when the circuit board was made, probably when the unit was assembled. So talk about just-in-time delivery for the parts. The parts arrive at the factory and these things are popping out as quickly as they can get the parts in for them. Interesting. You'd think they were making a car. That's how the car industry is, right? The parts show up. Basically, within hours of when a car is being made, the parts are rolling off of a train, and they're going right to the assembly line and being assembled. Moment of truth. We'll apply power and watch the smoke begin. Better not smoke. Yeah, let's turn it on. See whether it does anything. No power. Just looking for any voltages, any sign of life in this power supply. Doesn't appear to be that it's starting. Nothing. So the oscillator's not kicking in. When we get voltage here, we should have, I gotta measure this to the hot ground, but might be this cap over here. That might be the boot cap that starts it. Even though it tested okay, that one might be bad. We'll just pull the power supply again. We'll pull that cap out and actually measure it outside of the board. Now this bloody thing is going to be charged. It's going to probably have about 170 volts on it. So now is the time I could get bit. Big filters down here. Yeah, it's discharging. Okay, it's down to 3 volts. Must be a bleeder resistor on here, which I mean, they all should have that anyway. All good power supplies should have a bleeder resistor, just to make sure that everything discharges when the power is off. Could be the MOSFET too, but unlikely. Usually it's a boot up capacitor that's bad. In this case, it could be an open resistor too. I don't see any, well, it could be, there's surface mounted resistors on this one, but it could be an open resistor that supplies the bias to start it, or a bad filter cap. There's a couple of resistors down in here which certainly could, if they went open, cause this thing not to start. So we'll check this cap first here, and this electrolytic over here, wherever the heck it is, right here. We'll check that one first, and then I'll start measuring some of the resistors in the primary side. It's going to be a problem on the primary that's gone bad. Those caps that I changed definitely were bad. They were leaking, so they had to be changed, but there's more problems than just that. It may have, I mean, it even could be the IC. It could have gotten walloped. It was, when it, as I say, it worked fine until we had a power failure, and then when the power came back on, this didn't start. So there could have been a surge that happened when the power went out or came back that could have caused some damage to the power supply. There's a 35 volt, 68 microfarad. Let's just measure this one. Oh, it's measuring okay. Now that cap's definitely not gone. It's going to be a resistor, I think. It's got to be a resistor in the bias circuit that starts it up. So I'll just put that cap back, and we'll start examining the power supply, the front end of it. I'm going to go and see whether I can find a manual for this thing. Probably won't be able to find one. I'm going to have to just go through it in my head and try and figure it out. Just trace it by eye, and it goes to one terminal of the IC, and then it comes down here and it goes through a Zener diode, and there's a resistor here. So maybe one of these components, we'll just measure them all. So far these resistors are all testing good. That's a 15K, this one, so we just measure that, and it's 15K on the meter. Next one over is, what's this one here? This one's 4.7, looks like. That's going to be good. This one's also 4.7, measuring 3 ohms. That's within spec. This one here is just a jumper. 0. I think that's a jumper. All these resistors have tested good so far. Go with this diode here. Could be the IC. Could be the IC that's bad, the MOSFET. I'm just going to power this thing up. If I go down here, we'll turn it on, and we'll just measure across the capacitor. I should have like about 150 volts on here. I do. And where does it go from there? It goes down through this little coil. 166 volts there. I got nothing here. What the hell? Oh, I got it there. Well, we got the power on here. Let's just go on the secondary and see if there's anything coming up here when there's no load. So there's no oscillation, as you can see. This is just a single transformer, single winding transformer. So there's only one winding on the secondary. You got your primary here. This oscillator should start up, and we should have something on the secondary as soon as it is plugged in, but we have nothing. If I look at the negative terminal here, we should have voltage on. There we go. You see, we have voltage on the primary. That's weird. I was measuring to the positive terminal. Negative terminal on the cap, I would expect this would be. Well, what the heck? That's because it's backwards. I was looking at the ground. This is the ground side. It's marked as a plus. I saw the plus right here on the board, and I assumed this is the positive lead. That little plus is actually referring to the positive side of the rectifier. The trace goes around like this. The negative is going to that one. The positive is coming around here. This is the positive lead here. This is the negative lead. I just looked at the capacitor. You see the markings on the cap? That would explain why there was nothing showing up between here and between the negative terminal of the capacitor and this, because that's actually the negative terminal. It's grounded. So if we look at the negative terminal here, let's just measure our voltages now. Measuring to the actual negative terminal, which is that one right there. We should have a plus 150 or so over here. There we go, 167. So positive goes through the transformer. It comes up here. It'll end up on pin over here on the output. On the this is the. You guys can't even see that meter, but that was 167 volts there. Try that again. Negative terminal of the filter. This is the positive. This is the output for the MOSFET. So the voltage is there. The MOSFET is not oscillating. We'll just see if there's any bias to the MOSFET. To turn it on, there should be oscillating. There should be an oscillator running. And they typically just take a single pulse to start them up, and then once they start up, they start to oscillate on their own. There's the voltage going in, so it should be on. It should be running. It's got its It's got its bias voltage, looks like. .7, 19. It should be running. This bloody thing should be going. But there's no output, so I think the IC is shot. I'm going to have to see if I can source one of those. If I scope the IC, we'll see the pulse when I power it up. That should start this thing running. So you'll note when I apply power, okay, that pulse, that should start the oscillator running, but it's not. Therefore, the IC is cooked. Here's the other pin, you see? That oscillator should start up.
Wah, wah, wah. That's it. That's it for this one. This one is dead. I'm going to have to try and find one of these parts. Fun times ahead. Stay tuned. If we find a part, we'll do a part 2. Yeah. Thanks for watching. Catch you later.